Alright, so now we're down to our back page, the last set of problems. Well, actually, there are 14, but it's the last page. So I can factor out from number 1, I could factor out a 3x. So I'm going to go ahead and do that. I get x squared plus 7x plus 10. And then you look in the parentheses, and that's a trinomial. So you look for factors of 10 that add up to 7. Okay? So factors of 10 that add up to 7 are 5 and 2. 5 times 2. So now I just rewrite 3x, and then x plus 5, and x plus 2. So there's the answer for that. For number 2, the greatest common factor, the GCF, is x squared. So that gives me x squared plus x minus 56. And so now I'm looking for factors of negative 56 that add up to positive 1. So the factors are 7 and 8. Well, one of them has to be negative, right? Because you want a negative 56. So if I want my result to be positive 1, that means that the 7 is negative and the 8 is positive. So you would say, bring down the x squared, x minus 7, x plus 8. And that's how you would factor that. Number 3, it's a 4-termed polynomial. So I'm going to set up the 2x2 grid, and I just put them in order as I see them. X squared. Oops, that looks kind of weird. Doesn't look like an x squared. So x squared, 5x, xy, 5y. And what's the greatest common factor in these two? That would be 5. And then something times 5. So, sorry, not 5. What am I talking about? X. That didn't make sense at all. Sorry. So greatest common factor is x. And something times x is x squared. That would have to be x. And then something times x is 5x. That would have to be 5. Then something times x is xy. That would have to be y. And then you just double check, is 5 times y 5y? The answer is yes. So that means that your factors are x plus 5 from up here times x plus y from here. Okay, number 4. Let's see, the greatest common factor here would be x. So 36x squared minus 64 after you factor out the x. And notice inside parentheses you have the difference of 2 squares. So there's really no work required here. If you recognize the pattern, difference of 2 squares, the square root of 36x squared is 6x, so you put 6x in both factors. The square root of 64 is 8. You put 8 in both factors. 1 is plus, 1 is minus. And you're done. Okay, number 5 is another 4-term polynomial, so let me move it up a little bit. So you draw your 2x2, and you put x squared, negative x d, 7x, and negative 7d. Okay? Greatest common factor in the top row right here is x. And then something times x is x squared. That would be x. Then something times x is negative xd. That would be negative d. And then something times x is 7x. That would have to be 7. And then you just check, is 7 times negative d negative 7d? Yes, it is. So that means that your answer is x minus d for up here, and then x plus 7 for here. For number 6, the greatest common factor here would be 5. So here I have 7x squared minus 20x minus 3. And then for this one, I do have to multiply the first one with the last one because the leading coefficient right here is 7. It's not a 1. If it was just a 1, then I would only look at that number. But because it's not a 1 right here, I have to multiply them. So I get negative 21x squared, and factors of negative 21 that add up to negative 20 would be negative 21x times 1x. Okay, those two multiply and give you negative 21 and add up to negative 20. So now from here, I can draw my little grid here. So 7x squared, negative 21x, positive x, negative 3. So the greatest common factor in the first row is 7x. Then x times 7x is 7x squared. Then negative 3 times 7x is negative 21x. Then 1 times x is x. And I check, is 1 times negative 3 negative 3? Yes. So now I have my factors. Don't forget the 5. And then x minus 3 from the top here. And then 7x plus 1 from here. Number 7 is another 4-term polynomial, so I'm going to do the little grid right away. xy, 8x, negative y squared, negative 8y. So the greatest common factor in the first row is x. Then right here, y times x gives me xy. Right here, 8 times x gives me 8x. Right here, negative y times y gives me negative y squared. And then I check, is 8 times negative y equal to negative 8y? Yes. So there's my answer, y plus 8 times x minus y. For number 8, the GCF is 2a. So then that leaves me with x squared minus 11x plus 30. So factors of 30 that add up to negative 11 would have to be negative 5 times negative 6. So my factors are 2a times x minus 5 times x minus 6. For number 9, if I could keep it on the same screen. Number 9 is the difference of two squares. So I'm going to set it up like that. So the square root of x to the 4th is x squared. And you put it there and there. And the square root of y to the 4th is y squared. And then plus, minus. Now the sum is, you can't do anything more there. But to this one, I can factor it again. Because this, this one right here is a difference of two squares. Okay, so I'm going to bring down the sum. That one we can't do anything else to it. But x squared minus y squared, I can factor it some more. So the square root of x squared is x. The square root of y squared is y. Plus, minus. So here's the final answer. Number 10 is a 4-term polynomial. So I'm going to draw the 2 by 2. X cubed minus 9x, 5x squared minus 45. Greatest common factor in the first row is x. Then x squared times x is x cubed. Negative 9 times x is negative 9x. And 5 times x squared is 5x squared. And I notice that 5 times negative 9 is negative 45. That works. So then I write x squared minus 9 for this. and then x plus 5. Now plus 5. Now x squared minus 9 is the difference of two squares. So this one's going to factor again. So it's going to be x plus 3, and oops, I have the x minus 3. And then bring down the x plus 5. So here's the final factored form. 11 is another 4-term polynomial, so I'm just going to set it up. 2ax squared, 8ax, x, and 4. So the greatest common factor in the first row is 2ax. So then I have to multiply by x to get 2ax squared. I have to multiply by 4, the 2ax times 4 to get 8ax. And then the x has to be multiplied by 1 to get x. Okay, and then you always check, is 4 times 1 equal to 4? Yes. So my factors are 2ax plus 1, x plus 4. Alright, 12 could be considered as a quadratic because I have this power twice as big as that power, and I have 1, 2, 3 terms. So we have to think of factors of 100 that add up to negative 29. And the factors are 25 times 4. So we're going to say, x squared minus 25 and x squared minus 4. Okay, now each of these is a difference of squares. So we're going to factor each of these one more time. X plus 5, x minus 5 for the first one, and then x plus 2, x minus 2 for the second one. And that would be the factored form. So number 13 I've already set up in a 2 by 2 because it's a 4-term polynomial, so I just set it up already. The greatest common factor in the first row is y squared. And then something times y squared is going to give me this, so that would be x squared. And then something times y squared is going to give me this, so that would have to be negative 1. And then finally something times x squared is going to give me this, that's going to be negative 15. And then I just check, is negative 15 times negative 1 positive 15? Yes. So my factors are x squared minus 1 and y squared minus 15. The x squared minus 1 is a difference of squares, so we're going to write that as x minus 1, x plus 1. This one is not difference of squares, so we could leave it like as it is, and that would be the answer. The GCF for 14 is 2x squared, so I'm going to go ahead and take that out. Factor it out, so I get 4x squared plus, 28x plus 49, okay? So I'm going to check, this looks like it could be a perfect square trinomial. So the square root of 4x squared is 2x. The square root of 49 is 7. When I multiply 2x times 7, I get 14x. And when I double it, when I multiply it by 2, I get 28x. And that's exactly what I have here in the middle. So yes, it is. So that's kind of nice because now all I have to do is bring down the 2x squared, parentheses around the 2x and the 7. I'm going to put a plus in between them because there's a plus right here, and then put a square. And I'm done.